Hello children. Now we discuss about the second numerical of the same topic, motion in one dimension. In the given question, a ball which is thrown vertically upward reaches the roof of a house 100 meter high. At the same moment, this ball is thrown vertically upward. Another ball is dropped freely from the roof of the house. At which height will the ball pass each other? The value of G is given 9.8 meter per second square. So now we have to consider the building, and the height is given according to the question 100 meter. So one ball is thrown vertically upward. We have to consider with initial velocity u. At the same time, that means time is same, the another ball is dropped from the roof of the building. For the freely fall body, initial velocity is 0. Let us consider the first ball is cover the distance h1, and at the same time the second ball is cover the distance h2 from the roof. So it is the intersection point, and we have to consider at this point both ball is passes to each other. So in this case, the first ball is cover the distance h1 in the vertical distance, and second ball which is dropped from freely from the roof, it will be cover a distance h2. Now apply the second equation of motion for the first ball and for the second ball. For the first ball, the distance is h1, so h1 equal to h equal to ut, but ball is thrown upwards, so g is negative, so ut minus half gt square. Time is considered t. It is the first equation. Now at the same time the second ball is dropped from the roof of the building, so h2 is equal to initial velocity is 0 for the second ball, t minus 1 by 2 gt square. But for the second ball which is dropped from the roof, the sign of g is positive, so h2 equal to half gt square. It is the second equation. Now adding the first and second equation, first plus second, so LHS h1 plus h2, you see, and RHS, it is minus half gt square, it is plus half gt square, it is cancelled, so only ut is left. So h1 plus h2 is the total height of the roof of the building. It is given 100 meter. So in the place of h1 plus h2 we have to write 100 and it is equal to ut, equation third. Now find out the initial velocity of the first ball. Let us consider the first ball is cover the particular height 100 meter, and final velocity becomes 0 at the roof, at the top of the building. So according to the third equation of motion, v square equal to u square minus 2gh. V becomes 0 at the roof, u is given, it is a known quantity, so you have to find out u square minus 2, g is 9.8, and height is given 100. So u square equal to 9.8, that is 2 into 980, that is 1960. So initial velocity u equal to root 1960. Now we put the value of u in the third equation, so it is equal to 100. U is 1 root 1960 into t. So find out the time, t equal to 100 upon root 1960. So time is find out. Now the value of time t we put in equation second, h2 equal to half gt square. So h2 equal to half gt square are in first equation or second equation, if you want to h1 or h2. So h2 equal to given, h2 equal to half gt square, so h2 equal to half gt square. So it is 1 by 2. G is acceleration due to gravity 9.8 and time is given 100 upon this one, square of this value. So 100 into 100 upon square of under root 1960. It is equal to 1960. Decimal is cancelled. Here 10. 98. It is 200. 20 is cancelled. 100 is cancelled. 2 2s are 4 and 4 25 times 100. So H2 equal to 25 meter. So from the roof of the building at 25 meter distance, both bodies pass to each other, across to each other, or from the ground at 75 meter distance, because 100 minus 25, it is 75 meter distance, both bodies cross to each other. Thank you.